Uh, Good afternoon, everyone. I want to welcome you to. I think this is going to be the final revision before midterm two. And as I promised on Monday, I've already published the recording for Monday. You can check the canvas. Of course, today I'm going to continue with what we started on Monday. And all what I need from you is just for you to sit back and ask questions where necessary. I believe the moment you follow what I'm going to be doing, um, the midterm two is going to be a walkover for you. So now I told you on Monday, the midterm two will revolve around chapter 4, 5, and 6. And on Monday, I have already walked you through chapter 6. Okay, I'm going to start this with chapter 5. I told you there's going to be 30 multiple choice questions and 15 questions will revolve around chapter 5 and 6 and 15 questions on chapter 4. So which means there's a lot of questions for chapter 4. Okay, now I'm going to start. Somebody asked a question because I was reading my email yesterday and somebody said, are we going to be told the name of the distribution in the test? Let me just tell you this. If we're talking about continuous, of course, you're going to be told for continuous, okay? Whether uniform, normal approximation, exponential, gamma, beta, of course, you will be told about the distribution. Does that make sense? But for the discrete, you are not going to be told it. You are going to be the one that will figure it out for discrete. Okay, now because of that, I want to start with discrete. Right now, you're going to see in this question, I talking about Poisson distribution. Okay, now Poisson distribution is a probability, it's one of the discrete probability distribution. If X follow Poisson, with parameter lambda, we normally write the probability of this equal to that is this lambda raised to power x over x factorial. X start from 0, 1, 2. Okay. Now the mean expected value of s is lambda. The variance of s is lambda. Okay. The standard deviation of that is the square root of lambda. Okay. Now, part of what I shared the other time, if you check the link that I shared on the announcement section yesterday, of course, I share a link how you can use an online calculator for Poisson. Okay, so let's take a look. But let me tell you this. Before using an online calculator for Poisson distribution, you need to first identify your lambda. Lambda is very, very important. If you get your lambda wrongly, okay, you're actually going to have a very wrong result. Now, take a look at this question. We've already done this question in class. Here you're giving, suppose that the number of snake bite cases seen or die in a year as a Poisson distribution with an average 6 bite cases. Go ahead.
Can we use the online calculator on the test?
Yeah, yes. Because if you check my announcement section yesterday, I shared some link. Okay, I needed to check the announcement section. You are allowed to use online calculator for the test. Have I answered your question? Okay. Now, here, what is the probability that in a year, okay, the number of snake bite? Here I indicated Poisson. In another question, we may not indicate that. But the moment they mention a rare event, rare event, okay, rare event, event I will call in a blue moon, okay, and they mention, now they're talking about snake bite, we don't normally have frequent event of a snake bite. Now, question number one, the number of snake bites will be 7. will be 7. Okay, if I want to use the formula now, will be 7. If that's going to waste my time, will be 7. Okay, I'm actually going to use this guy here. Okay, what I've just done is I know my lambda is 6 and x equal to 7. I'm just going to plug in that, and that will give me 0.3768. But you know what? If you don't want to go by that, you can use the link that I share. Take a look at the link. Okay, Poisson distribution, lambda 6. Okay, now x equal to 7. I'm just going to come here and plug in 7. I've already plugged in my lambda. For exactly, you're going to see probability of x equal to that. When I compute that, what do I got? I got the same value. Any question about how I did it? This is using Poisson online calculator. Okay, like I said, all what you just need to do, you need to be able to identify what is your lambda and what is the values of x you are asked to find. Okay, now I'm going to go back to the question again. Less than 2. Now, if you want to do less than 2, okay, the probability of x less than 2, don't forget, this is not a continuous. This is a discrete. Less than 2 is going to be 0, 1. Does that make sense? Discrete, 0, 1. So I need the probability of s equal to 0 and probability of s equal to 1, which means if you want to go to the online calculator, you still going to indicate your lambda is still 6. Your lambda is still 6, except that you four of us compute. When s equal to 0, you get a result. When s equal to 1, lambda equal to 6, you get another result. Then you're going to add them up. When you add them up, you'll have the probability of x less than 2. Any question? Any question? Okay. Okay, now, if you take a look at the next one, what is the probability that in 2 years, what the lambda is going to change here? Because the lambda that was given initially is talking about in a year. Do you see in a year, right? In 2 years, then I'm not going to use, I need to multiply my lambda by 2. So in 2 years now, I'm actually going to have a new lambda. If you take a look at number 3, I'm going to have a new lambda, which is going to be 2 multiplied by whatever values of lambda that I had before. Now, then I'm going to continue, checking the table. Okay, in 2 years, lambda changes now because what you're giving was initially for a year. Okay, then you're going to proceed. Okay, now another one said, what is the probability that in a month? Okay, the lambda you were giving was for a year. In a month now, so something needs to happen to lambda. So I'm actually going to divide lambda by 12. You see, that was why here I'm actually dividing lambda by 12. So you need to be able to understand your lambda before you can, have any reasonable computation using Poisson distribution. You know what? I'm done with the Poisson distribution. And don't forget, if they ask you about average, it is lambda, the values of lambda. They ask you about variance. The mean and the variance are equal. Okay, are the same. The standard deviation, of course, is going to be the square root of that. So I'm done with the Poisson distribution. So don't waste your time, okay? Always make sure you, like I've already shared you the link. Now, I want to go to another distribution called geometric distribution. If I'm going to ask a question on geometric, I'm not going to tell, like I said, question on that discrete, I'm not going to disclose the distribution. You're going to be the one, that will figure it out. Okay, now I want to talk about geometric distribution now. Okay, why the Poisson distribution is actually used, to model real occurrence. The geometric distribution, on the other hand, we actually model, how many times am I going to fail before we record false success. You remember the other time in class when I cited an example of whether somebody watched a basketball game last night, somebody said no, 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 and the first time I see yes. Okay, so geometric, okay, so the probability of that, okay, equal P 1 minus P x minus 1, x start from 1, 2 to infinity. The expected value of s is 1 over P. The variance of s is Q over 1 minus p squared. Let me just q over p squared. So that should be q over p squared. Okay, don't forget, q here is 1 minus p. Okay, so which means I can, if I don't want to convince you, let me just write 1 minus p over p squared. Okay, now if you take a look at this, okay, how am I going to recognize that I actually need to use, geometry? Take a look at this. Assuming the each of your call to a popular radio station has a probability of connecting. Now, pay attention to the question. What is the probability? Your first call connects in your 10th call. That's geometry. Maybe your own exam is going to be like they perform operation, maybe 3 operation, and the successful one or call at the 3rd operation, stuff like that. Pay attention to all of that. Okay, first success, Yeah, you're actually going to use geometric here, like the question did not indicate that you should use geometric, but you need to be able to what are you going to see in a question, that we imply using geometric. Now, what is the probability that your first call that comes, that connects is your 10th call? 10th call. If I want to answer that, I already know my probability to be 0.02. And they say your first call that connects is the 10th one. If I want to waste my time, okay, if I want to waste my time, I'm going to use the formula here. Okay, that was what I used here. Take a look at that. Okay, 1 minus p, okay, 1 minus 0.02, okay, raised to power 10x here is going to be 10 minus 1, multiplied by that. That will give me 0.0167. I'm done. The probability of s equal to 10. But if I want to use the online calculator, if you follow the link that I share, I'm going to go into the geometric now. Okay, take a look at that. This is for the geometric one. Okay, all what I just need to do here, indicate is 0.02. As you see the probability of success, and what is the numbers of trial here? I take about 10, right? Taking about 10, then I'm going to click on that. Okay, so I click on calculate. Okay, oh my God, the beauty of this is going to give you a lot of stuff. Okay, but there's a difference between, this is exactly 10, okay, less than 10, at most 10, greater than 10, at least 10, but the question they ask you is exactly 10, okay? We're gonna go back now, see the question, okay? It's talking about, you see that? What is the probability, what is the probability that your first call that connect is your 10th call? Okay, what do we got here? We got 0.0167, and take a look at that. It's 0.016 to 4 decimal system. With online calculator, it's super easy. Do you know why you need to use online calculator? Because you're going to save your time for chapter 4. Chapter 4 are calculus intensive. Of course, you've seen, you'll be able to save your time for that. That's why you're going to use online calculator here. And that was why I shared the online calculator. Okay, I'm going to go back now. What is about? It requires more than 5. It just indicates s equal to 5. And if you want to choose, it's going to be greater than 5. The geometric online calculator is going to give you a lot of stuff. Does that make sense? So that's super easy. What is the mean number of core needed? Oh, mean number of core needed. Mean number of core needed. 1 divided by the probability given. So which is going to be 1 divided by 0.02 in this case. And that will be 50. I'm done with geometric. Any question? I'm done with geometric. So you should be able to understand formula for mean, for this, for variance. Of course, the moment you know P, here, the parameter on the geometric is actually P. Go ahead. Yeah, I'm gonna, if I frame the question, maybe no matter where I vary the question, whatever question I'm still gonna come within. What does it mean? What is the variance? Or what is the probability of less than, greater than, less or equal, stuff like that? Am I gonna give what? P, of course. Can I tell you something? If they don't give me P, there's nothing I can do as well. Okay, so they're going to give you P. P has to be given. Okay, just like what he said. Let's take a look at this now. P is given. Does that make sense? Okay, now I want to go into another distribution. Okay, it is negative binomial. You know, negative binomial is a generalization of geometric distribution. You know, it's just going to be what is the number of failures am I going to have before I started having a good number of successes. This time around is not just one success. Okay, you know, in the geometric, it's actually one success. And, you know, if I want to write the formula, you know, for negative binomial, okay, for negative binomial, the probability of x equal to that is x minus 1 combination this, gonna have p raised to the power that, 1 minus p raised to the power that, s start from r plus 1, and so on like that, okay? And, you know, the mean here is r over p. The variance is r 1 minus p divided by p squared. Take a look at that. When r equal to 1 here, you are going to find yourself here. When r equal to 1 there, you're going to find yourself here. Now, if you want to answer a question here, take a look at this. Just like what that guy said the other time. Suppose x follow a negative binomial. You know, if they did not mention the negative binomial in exam, but what you see is that, the 10th core or they mentioned that maybe somebody is seeing success, maybe maybe the second time or the third time of seeing success, not just the first time. Okay, please pay attention. Okay, you know, so that is what we mean. Maybe somebody perform operation, not successful, not successful, not successful. On the fourth one, successful. Another one not successful. Then another one successful. So success is coming. Okay, in more than one time, not just first time. Now, if I want to, of course, solving this problem now, you know, they ask you to find what is the expected value of x. That's going to be super easy. The moment I know how and I know p, I'm actually going to be done, you know. How here, okay, the how here is actually given to be 4 in this question now. It's given to be 4. So 4 divided by p, the p is given. That will give you the mean here. Now, what they ask you to find the probability of s equal to 20. Okay, if I want to find probability of s equal to 20, I'm actually going to make use of this formula. But you can use an online calculator, you know, make using this formula. You're actually going to get that. Now I'm going to share you with the online calculator for negative binomial. This is the online calculator that I shared, the link, you know, for negative binomial. I've already indicated. Number of event 20, number of success 4, then probability 0.2. You can see when I click on that, that gives me 0.04364. The same value that I got, you know, when I waste my time. The same value here that I got when I waste my time. Any question? That's super easy. Okay? So I want to believe, if I were you, you know, it depends on you, you know, just manage your time wisely. Okay? Now, that is that. Now, the next one is binomial. You remember this question in class. For binomial, we actually use, I think because of my time, because I want to talk about a lot of stuff. Of course, binomial is used, you know, to model like out of how many, out of so numbers of trials, okay, what is the probability of success? Okay? And in such a way, there are two possible nature, you know, two possible outcome, either success or failure. Okay, so that is what binomial is talking about. Binomial is not talking about first success. Binomial is not talking about fifth success. But binomial is talking about out of how many trials, how many successes do I got? Does that make sense? That's what binomial is talking about. Take a look at this example. The probability that a patient recover from a rare blood disease is 0.4. You know, the probability is given. You know, they say recovers. A patient could recover or not. That's, you know, the possible outcome here is dichotomous. Now, if 15 people are known to have contracted disease, what is the probability? Now, let me tell you this. 15 people have contracted disease, like you're having 15 trials. Now, how many are going to recover? Then it means you are looking for the number of success. Does that make sense now? Because in the exam, they may not going to tell you it is going to be binomial. Now, what is the probability at least 10 survive? At least 10 survive, mathematically speaking, if you want to use binomial table, right? At least 10 survive is going to be that guy. The probability of s greater or equal to 10, which is going to be 1 minus that, okay? And that I'm going to, but all of this is going to waste my time. I show you the other time, we got a binomial table, but I also share the link of binomial calculator as well. Okay, you want to find that. You know what I'm going to do? Okay, I'm going to show you my calculator for binomial now. You see, the calculator for binomial, all what I just need, what is it? What is the number of trial 15 patient, right? I indicated 15. What is the probability of surviving? I indicated 0.4. And let me see, what was X? Okay, at least 10 survive. Now, what I'm gonna do, I'm actually gonna come here now. I'm gonna put 10. 10. Okay, now at least. Then I'm gonna go to the drop box. At least it's gonna be greater or equal. Take a look at that guy. That's greater or equal. I'm gonna compute that. Okay, at least 10 survive. That's what I got. 0.0383. Let me see. Is that what we got? Oh my God, take a look at that. That's what we got. Instead of wasting your time, you can just use binomial calculator online. Okay, any question on this? Any question? Do not be scared. You pay for the service. Ask question. If you pay for this, you deserve to ask question. Why is that guy sleeping? What's happening? You okay? You okay, right? Good job. Now I wanted to be sure if you're okay. Okay, now, if you go to the next question, 3 to 8, right? The other time 3 to 8, we're going to do 8 and 2 cumulatively. All what I'm just going to do is just to go into that online calculator, indicate 8, but I'm going to press less or equal, indicate 2, less or equal. I'm going to get 2 values, I'm going to subtract them, and we're actually going to have that. Therefore, exactly 5, okay, for exactly 5, okay, let me see, in the online, let me see whether I have equality in the online calculator here. Oh, there is equality. Okay, so what I'm going to do here, exactly 5, I'm actually going to put 5. Then I'm going to come right here, equality. Okay, computer, that give me 0.18594. Let me see whether it is the same as what I got for it. Oh my God, that is the same as what I got here. And if you want to make use of the table in your textbook, you're going to go by this, you're going to be wasting time. Okay, so that is that. Take a look at that. That's binomial. Now, the next distribution is multinomial. Unfortunately, there is no online calculator for this. But if you take a look at, because it's not as if there's no online calculator for it, but you also need to know how, in this class, it's not going to be only about checking for something online. You also need to know how to do some stuff manually. Okay, now multinomial. Multinomial is a generalization of binomial. In multinomial, the number of, it's like we got more than 2 possible outcomes. Okay, in binomial, you got 2 possible outcomes. In multinomial, that's why it's called multinomial. Okay, and how am I going to know? I'm working with multinomial. Okay, you're actually going to be given at least 3 categories. Okay, at least 3 categories. Take a look at this. You got runway 1 up to runway 3 with 3 probability. It means any question where you have more than 2 probability. They give you probability for this. Maybe they play in a game. They give you probability of winning, the probability of losing, probability that is going to end in a draw. How many categories are 3, right? winning, the probability of winning, the probability of losing, the probability that a game is going to head in a draw. That's a three possibility. Now take a look at this. You're actually going to have three probability given, and not only that, they're going to give you a random variable that can be partitioned into three. Okay, the random variable was actually 6. Take a look at that, 6. And 6 was partitioned into 2, 1, 3. Okay? So, and if you, the formula we're using, of course, is the formula of multinomial. So, expect a question from multinomial. Now, apogeometric 2. Okay? You know, we have two categories. The difference between apogeometric and binomial is that apogeometric we sample without replacement, while with binomial we sample without replacement. Take a look at that. You know, a question like that, you got two categories. Okay, where you are choosing. Okay, here now you're gonna choose. You want to choose 3 out of 10. Choosing 3 out of 10. The 10 is a sample, and that can be partitioned into 2 and 8. If you take a look at that, a particular part that is used as an injection device is sold in a lot of 10. The producer deemed a lot acceptable if no more than 1 is effective, is in the lot. A sampling plan involves randomly sampling and testing 3 of the parts. Okay, sampling 3, only 3 of the part out of 10. 3 out of 10. This is where you use choose 10, choose 3. Okay, in your calculator. And now, comment on the utility of this plan. Let us assume that the lot is truly unacceptable, that 2 out of 10 are defective. 2 out of 10 are defective, which means the numbers of defective is going to be 2. Automatically, the numbers of not defective will be 8 because you got 10, right? Now, the question now is unacceptable now. It said, comment on the utility of this plan. Let us assume that the lot is truly unacceptable. If 2 out of the 10 parts are defective, then the probability that the sampling plan find a lot that is acceptable, a lot that is acceptable is having, what is that? 0 defective here. Okay, the question will indicate that. Okay, the question will indicate all of that. So you can use your calculator there too. Lastly, multivariate apogeometric. In the case of multivariate, multivariate apogeometric and multinomial, they are very close. I'm going to say that again. Multivariate hypergeometric and multinomial, they are very, very close. Okay? This is an extension of hypergeometric. Okay? The difference is just that hypergeometric that I showed you the other time, we only have 2 categories. But here we got more than 2 categories. Okay? Then you're having 3 categories. You see that? You're choosing 10. Okay? And if you take a look at that, a group of 10 individuals is used for a group of 3 people with a blood type O4 with blood type. They've already given you the number in each category. Okay? Then what is the probability that a random sample of 5, this is a sample of 5, is going to be choosing? And when that 5 is choosing, they're actually going to tell you how it is distributed. Okay, 5 choosing such that 1, 2, 2, 1, 2, 2, 1 come from that, 2 come from that. All what you just need here is to use your calculator. Okay, you're actually going to be fine. Because of my time, I'm done with the 2 distributions. They are discrete. I want to go to chapter 4. That have 15 questions. But you know what? I decided I did not put a rigorous calculus. I just put the basic one. Okay, now I need you to take a look at, I'm gonna go into the example of such questions now. Okay, it's something you've done before. And we're gonna have some from discrete and some from continuous. But I first gonna show you the one from, take a look at this question. Mathematical expectation for discrete. Anytime you are giving probability and you are giving random variable with their possible probability value, okay, then you can actually obtain the mean. The expectation of the mean, okay, is actually, we're focusing on profit here. Profit becomes a random variable. And this is the probability of making profit. You remember what we did in chapter 4, expectation of x, multiplying, the random variable with the corresponding probability. Then after doing that, then you're gonna add them up. Okay, when you add them up, there's gonna be. Why is the answer not reflecting here? I think the answer should maybe A. It's not reflecting here. So is there anyone who doesn't understand, like, the formula that we used before, in under mathematical expectation, when we're talking about discrete, expected value of x is summation this, okay, multiplied by this, which not, so here now, because we're focusing on profit, it's going to be this times that, this times that, this times that, then you're going to add them up. But don't forget, one has a negative here. You remember why in middle school you do integrals, adding integrals, -5 plus -6, stuff like that. Okay, that's super easy. Now, you remember we did a linear combination of random variable? Okay? You given expected value of x equal to 2, expected value of z equal to 4. What is expected value of that? Okay? Now, expected value of z minus x is expected value of z minus expected value of x. That's super easy, right? Now, what is the expected value of z? Expected value of z is 4, right? What is the expected value of that? 2. 4 minus 2, 2. I'm done. Stuff like this. Okay, this comes under linear combination. Okay, now let me go into the rigorous one. Take a look at this. You have, this is where calculus is now. You have a joint probability distribution giving f of xy equal 10x squared y. But let me tell you this. I'm not going to give you a complicated function in exam. Okay, and I need you to pay attention to this interval. 0 less than y less than x less than 1. There's possibility in your exam you may get this this, or you may get the one that will come with a separate interval. Does that make sense? Separate interval, the interval of x, the interval of y. Now here, the question here is asking about what is the f of x? Oh, am I going to get f of x? Okay, if I'm going to get f of x, okay, f of x is integral f of xy dy. If I'm looking for f of x, I will perform antiderivative with respect to the variable I'm not interested in. Okay, now, if it's I'm integrating with respect to y, look at the state space. What is going to be the state space for y? It's going to be 0 to x. 0 to x, based on what you see there. Okay, now what that guy is trying to tell you now, okay, I actually have 0 to x, 10 s squared y the y. Okay, I'm going to integrate this now. It's going to be 10 s squared y squared over 2, because I'm integrating with respect to that. Okay, from 0 to x to algebra 5 s squared y squared 0 to x. So I'm actually going to have this, which is going to be 5x4. Okay, that was how I got a 5x4. Okay, now that is the f of x. Okay, the moment your f of x is right, then this is going to be right. Because you want to find the expectation of x, you actually need f of x to do that. Because the expectation, okay, the expectation of x is integral x f of x dx. Okay? So integral x f of x dx. And the range that you are, if you want to find the mathematical expectation, you're actually going to use the general range, 0 to 1. If you take a look at in the range, you can see 0 to 1. But if you want to find the function, it's not going to be 0 to 1. So here now, so 0 to 1, okay, 0 to 1, x. What is my f of x? This guy. 5x4 dx. So I'll simplify 5x5 dx, 0 to 1. So that's going to be, if I integrate that guy now, so 5x6 divided by 6, 1 and 0. Okay? So Now you're going to plug in 1 and plug in 0. So that should give you 5/6. Okay? So that was why you got that 5/6. Okay? Now for you to get the correct value for expected value of x, you need to first figure out how f of x. If you want to get the expected value of y, okay, because I know they're going to ask that. Okay, now, before, how do we get expected value of x squared? Okay, expected value of x squared is still going to rely on the correct value for f of x. So expected value of x squared now, okay, I need to do algebra. Expected value of x squared is integral s squared f of x dx 0 to 1. So 0 s squared, what did I get for my f of x? You know, I'm seeing using that 5x4 dx, which is going to be 0 to 1, 5x6 dx. I thought first simplify before I perform the antiderivative, and right now it's going to be 5x7/7. When I integrate that from 0 to 1, if I put 1 on that, I think that should be 5/7. Okay, so that was how extra 18 is 5/7. You see the way I did to expected value of x, expected value of s squared. And you know what? Oh, if 17 and 18 is correct, then I will be able to compute my variance in 19. Because the variance is expected value of s squared minus expected value of s squared. If question 17 and 18 is wrong, if your answer in 17 and 18 is wrong, then your answer is 19 will be wrong. Now, I've talked about something that has to do with x, right? I got f of s, I got expected value of s, I got expected value of s squared, I got the variance of s. I'm going to do the same thing to y. If I want to start with the y part, I also need f of y. You see the way I'm getting my f of y? Okay, my f of y is actually, let me look at the time. Okay, now my f of y now so my f of y is going to be, you're going to go back to the range, okay? And you know, I want to integrate it with respect to x, okay? Then I'm going to be needing the range of x here. And if you take a look at the way here, the range of x here is between y and 1. Y and 1, okay? Now, if you take a look at this now, y, 1, what was the f of x, y? 10x squared y dx. So here now, I'm going to have 10x cubed over 3 y 1, that one. Then I'm going to have 10 over 3 into, okay, into 1, or sorry, y, okay, 1 raised to power 3, y raised to power 3. Take a look at that, okay, plug in what I'm plugging now, wherever I see x, I'm plugging 1, okay, so which means this guy, that's a constant apart from x. Okay, 10y, so 10y over 3. Wherever I see x, I plug in 1, and I plug in y, then I got this. So this is going to be the function 10y over 3, 1 minus that. So this is my f of y. So if I want to find the expected value of y, I need to know this. If I want to find the expected value of y squared, I need to use that. Okay, so I think saving my time, you can try all of that. Check it out. You see what I got f of y here, right? And I want to get the expected value of y. You see what I'm doing here? Expected value of y, okay? Expected value of y is going to be integral y, f of y, the y. Now, don't forget, when I'm doing expectation, I will use the natural, range, 0 to 1. That is being reflected. And your f of y is what I derive here. You can see, that's what I'm trying to show. If you take a look at that, and the final result of 5/9. Now from there, I'll proceed the same way, get the expected value of y squared. You're going to try that. Then I'll be able to get the variance of y, okay, which is going to depend on where you get in 21 and 22. Then I can get, okay, this is very interesting. Expectation of a product, x and y. And I'm going to show you now how you actually going to get that expectation of a product. Because you're going to need expectation of a product for you to be able to answer a question that has to do with covariance or correlation. Now, the expectation of a product, okay, now if I want to get the expectation of a product, okay, integral, okay, I can decide, I'm going to start with, I will advise that you first start with y before you start with x, okay, value 0 to 1, 0 to x, okay, xy, f of xy. Now, and for situation where 0 less than y, okay, less than x less than 1, take a look at this, which means what am I telling the world here? I'm trying to tell the world y lie between 0 and s. You see that? Y lie between 0 and s. Do you see? Here, y lie between 0 and s. Okay? Now, and the general one first, 0 to 1. I'm assuming 0 to 1 for x. Now, in this case now, I'm going to have 0 to 1, 0 to x, xy. What was that? 10s squared y, okay, the y, okay, the x, okay, I need to first do algebra here. Simplifying that, I'm going to have 10 s cubed y squared. Okay, let me first integrate this with respect to y first. Let me do this one first. Okay, if I integrate this one with respect to y, that's going to be 10. Okay, this y3 divided by 3 from 0 to x. Okay, anywhere I say y, I put x. So this is going to be 10x6 divided by 3. Now, the moment I got that, then I'm now going to integrate now. I'm going to integrate that of 0 to 1, 10x6 over 3, okay, dx. Okay, so which is going to be 10x7, 7 times 3, 21, 1, 0. So 10 over 21, 1, 7 minus 0, 7. That should be 10 over 20. Oh, okay, so that should be 10 over 21. You see that? But let me tell you this. Maybe in the exam, I could give you, when I give you this, a separate range, that would be super easy, right? Okay, so maybe you should be expecting this. But I'm just in case you see something like that. And you know what? The moment you get your expectation of a product, you'll be able to get your covariance. Look at the formula for covariance. That depends on that. Okay. Now, and they ask you, are they independent or not? If the covariance equal to 0, okay? If the covariance equal to 0, they are independent. If the covariance is not equal to 0, they are not. Then you can get the correlation. Okay, the correlation is going to be covariance divided by the product of the two standard deviations. Don't forget, we've gotten the variances before. Square root of the variance will give you that. Okay. I think I've done 29 and 30. There is one more important thing that is not here, and it's going to come out in this exam. Please focus. There is one more important thing that is going to come out in the exam that is not, here, and it's this. I'm going to use my last. Take a look at this. If I have y1, 0, 1, 2, a table, okay, and I have y2, 0, 1, and I have 0. This is 0.09, is 0.01, and I have a total, okay, 0.30, okay, and here is 0.41, okay, shear, okay, the table that we normally give for joints, right? Okay, you have this guy, is 0.3, 0.09, and this. I gave you this table in midterm 1. What of in the situation, do you know they can ask you to find what is the expected value of y1? Okay, expected value of y1. Okay, this is another total. if I want to get the expected value of y1, okay, see, I'm going to multiply that guy by that guy, this by this, that by that. I'm going to add them up. That would be the expected value of y1. You remember? Let's say mathematical expectation when you are working with the discrete. That is going to give you expected value of y1. Because y1 here has 0, 1, 2. And the total, look at the total here. These are the probability for that. What about the expected value of y2? Okay, for y2, this multiplied by this guy, this multiplied by that guy, you add them up. That's going to be the expected value of y2. Okay? Now, the same way you can also be asked to find expected value of y1 squared, expected value of y2 squared, the variance of y1, the variance of y2. Okay, here, expected value of y1 squared minus expected value of y1 all squared, expected value of y2 squared minus expected value of y2 all squared. You can also be asked the covariance of y1, y2. Okay, now, if you want to get expected value of y1 squared, please focus. Expected value of y1 squared, you first square this before you multiply by this, square this, multiply by this, square that, multiply by that, you add them up. That will give you the expected value of y1 squared. So this is like y1 squared, the probability of y1. Okay, this is, and here y1 is going to go from 0 to 2. Here, y2 is going to go from 0 to 1, y2 squared. You see that? The moment you get this and you get this, and you get this guy and this guy, you'll be able to get the variances. Now, how am I going to get the covariance? Before getting the covariance, you need to first get the product. Now, I need it to be focused. How am I going to get the product? Product. 0, 0 times this. 0, 0 times 0.20 plus, you see the way I'm taking the product? 0, 0 times this. Now, 1, 0 times that. Okay, 1, 0 times 0.09 plus 2, 0 times 0.01 times 0.01 plus 1, 0. You know, anywhere you see that 0, you know, what you're going to see there is just going to be like, yeah, it's 0. This is going to be 0. This is also going to be 0. That would be super easy. It's going to be 0. The only one that will not be 0, if you take a look at this table, the only one that will not be 0 is 1, this guy, 1, 2, this guy. Okay? Is there any other one that will not be 0? No. That would be super easy. I would deliberately put something like that you only need just few one. And the moment you get you get this one, expectation of the product, then the covariance will be expectation of the product minus this times that. Don't forget, you've gotten this and this before. Then when your covariance is 0, they are in the S, then the two variables are independent. When it does not give 0, they are not. Just like what I used to say. You already know what is coming. Or what I want you to do. You can work with your colleagues. You know, review everything that I've done today. Okay, like this is being recorded. I'm also going to share the recording today as well. Like I said, you are not going to be here on Friday. You can choose to start at any time you want between 6 a.m. and 11:59 p.m. When you are not ready to start, don't click. Because if the moment you click, your time is going to be running out. Okay? But you know what? Do not be scared. Tell yourself you will succeed. Okay? See you on Monday. Bye for now.